Hello, welcome to the Math Bunker. I'm Dr. Hein, and you're watching Math on Canvas. Today we're asked to find the value of x, and we have a triangle with two tick marks indicating this is an isosceles triangle. An isosceles triangle has two sides that has equal sides. And when they have two sides that have equal sides, and it's an isosceles triangle, the opposite of those sides have equal angles. So we have this triangle, we'll call it triangle, I'll go counterclockwise. We'll call it angle 1, angle 2 is noted by the 2, and the 96 degrees represents angle 3. We're asked to solve for x. The lowercase m stands for the measurement and the angle symbol of 2. So the measurement of angle 2 is equal to 3x plus 12, and want to solve for x. So we're going to use first the isosceles triangle theorem to figure out what the measurement of angle 2 is, and then we're going to substitute that information for the measurement of angle 2 and then solve for x. So let's do that first. Okay. So we know that all three angles, angle 1, 2, and 3, the sum is 180 degrees. And so the first thing I'll do is I'll simply subtract 96. And that's the measure of angle 3. 180 minus 96 is 84. So now that we know that angle 3 is 96, 1 and 2 shares 84 because they're equal. So I'll simply take 84 and I'll just simply divide it by 2. 84 divided by 2 is 42 degrees. Therefore, angle 1 and angle 2 is 42 degrees. Okay, so now that we know that the measure of angle 2 is 42 degrees, we can substitute 42 degrees for the measure of angle 2. And I'll do it right now, 42. Remember that 42 stands for, it represents the measure of angle 2 in this formula to the left. So 42 equals 3x plus 12. And now it's a fairly simple equation. What we'll do, we'll isolate x. We'll make x all by itself on the equal sign. Now, what we do is we work on the side of the equal sign that has the x, the 3x, but as far away from the x as possible. So we have a positive 12. To move it over the equal sign, we have to do the opposite operation, which is addition, subtraction, multiplication, division. Its operational sign is addition, so I'm going to subtract 12. 12 minus 12 will vanish. It will cancel out. Because I subtracted 12 on one side of the equal sign, I must subtract 12 on the other side of the equal sign. And our equation will continue to stay balanced. So 42 minus 12 is 30. And that will take care of this on the left side. I'll drop down my equal sign, and then I'll drop down my 3x. Now I'm left with 30 equals 3x. Now 3 is called a coefficient. It's the number in front of the x, which is the variable. And anytime that they're touching and in the middle between the 3 and the x, if you do not see addition, subtraction, or division, it's automatically multiplication. But again, to move it over the equal sign, we have to do the opposite operation. The operation is multiplication. 3 times the number equals 30. Its opposite operation, multiplication, is simply division. So 3 divided by 3 is 1, and that leaves me with 1x. X is by itself. Now, again, let's keep this equation balanced. Because we divided the right side by 3, we must divide the left side by 3. And 3, or rather 30, divided by 3 is 10. Therefore, when we're asked to find the value of x, and we're given an isosceles triangle, and we know the degrees of one of the angles and opposite of the congruent sides, after we subtract the 96 from the 180, when we divide that by 2, we take that information, which was 42, we plug it back into this equation, substituting the measure of angle 2 for 42, and then we solve for x. And so x does equal 10. Thank you for joining me, and you are watching Math on Canvas.